Hi, this is Jack from Maths Forge, and in today's lesson, we're going to be solving simultaneous equations. To solve simultaneous equations is to find the x and the y value of both equations. How we do this for linear simultaneous equations is using a method called elimination. So let me show you what that looks like. So whenever I perform a calculation, I always like to rule off. There's no rule about doing this, but you can do this to just keep your working out organized. So why is the method called elimination? Well, you can see here that your x value of the top equation is 3x and your x value of the bottom equation is 3x. So they actually hold the same value. Y does not. And then we have the numbers that also do not have the same value. Whichever variable has the same value, you can go ahead and eliminate them. And we do this by subtracting one equation from the other. So in this case, I'm going to do the top equation minus the bottom equation. And that looks like this. I'm going to put a little minus symbol here to show what's happening. 3x minus 3x is 0, so they've cancelled out. There's no need for you to write the 0 here. 4y minus 3y just gives us y. And then finally, 10 minus 9 gives us 1. And just like that, we found the y value, which is equal to 1. Now we need to go ahead and find the x value. And we do this by taking this y is equal to 1 and substituting it into one of the equations. Which equation you substitute it into is entirely up to you. I'm going to use the bottom equation because the numbers are smaller overall, and therefore the numbers are going to be easier to calculate. So I'm going to write out my 3x plus 3y equals 9, the second equation here. 3x plus 3y. Instead of actually writing the y that's there, I'm going to replace it with the y that we found, which is 1. So it's going to be 3 times 1. Don't forget that 3y is 3 times y. And since we found y to be 1, it's going to be 3 times 1. And this is equal to 9. Now I'm going to go ahead and simplify this. 3x plus 3 times 1 is just 3, and this is equal to 9. This now becomes a two-step equation. So I'm going to rearrange for x by cancelling out this plus 3 first, and I'm going to do this by subtracting 3 on both sides. This is now going to give us 3x, which is equal to 6. And for the final step, I'm going to get rid of this times 3 by dividing with 3 on both sides. This is now going to leave us with x is equal to 2. So here we have solved these simultaneous equations to give us y is equal to 1 and x is equal to 2. And if we check our answer, there it is. So now let's do a 2-star example. Again, we're being asked to find x and y for these simultaneous equations. I can see this time that my y variables are the same, where my x variables are not. So let's go ahead and eliminate our y variables. I can see here that this y variable here is a positive 4y, whereas this y variable here is a negative 4y. Don't forget to include the symbols to the left of the terms. How do we eliminate positive 4y and negative 4y? If I try to subtract them, what will end up happening is that these two negatives become a positive, and then I end up adding them together to give us 8y. So subtracting these equations will not work. In order to eliminate the two 4y's, I have to add these equations. Because of course, when you add a negative number, it's the same as subtracting it. And so adding these equations together will actually end up eliminating the 4y's. A general rule of thumb is that when your symbols are different and your variables have the same value, you add them together. And if the symbols are the same, you subtract them. In this case, the symbols are different, so we're going to go ahead and add them together. So I'm going to do 5x plus 2x, which gives us 7x. 4y plus negative 4y gives us 0, so we don't need to write that down. And then we're going to have 42 plus negative 28, so 42 plus negative 28 is the same as doing 42 minus 28, which gives us 14. So I'm going to go ahead and write that here. And now we have 7x is equal to 14. We can go ahead and rearrange for x quite simply just by dividing both sides of this equation here by 7. This now leaves us with x is equal to 2. Now that we found x, we can go ahead and take this value and substitute it into one of our original equations. The equation I'm going to choose to substitute this x is equal to 2 in is the top one, as the bottom equation has some negative values and I prefer to work with positive values. So we're going to write down our first equation here, 5x plus 4y is equal to 42. 5x, but instead of x, I'm going to write down the value that we found for x, which is 2. And then we're going to have plus 4y, and this is equal to 42. If we simplify this, we get 10 plus 4y is equal to 42. This now becomes a two-step equation that we can solve. So the first thing I'm going to do is get rid of this 10, and I'm going to subtract 10 from both sides. This is going to leave us with 4y is equal to 32. Now I have to get rid of this times 4 onto the y, and I'm going to do that by dividing with 4 on both sides. This now gives us y is equal to 8. And now we have our solutions. X is equal to 2 and y is equal to 8. And if we check our answer, there it is. X is equal to 2 and y is equal to 8. Now let's do a 3-star example. Here we're being asked to find x and y for these simultaneous equations, but there's a problem here. None of the x variables or the y variables are the same. We have a 5x here and a 4x here, and a 4y here and a 7y here. So we can't eliminate them straight away. To get past this problem, we're going to choose one of our variables to have the same values. In this case, I'm going to get my x variables to be the same. How do we do this? Well, this 5x here and this 4x here, I'm going to take the coefficients of each of them. So I'm going to take the 4 here for the second equation, and I'm going to multiply it onto the first equation. I'm then going to take the 5 from the first equation in front of this x and multiply it onto the second equation. And the reason for doing this manipulation is because it's going to give us the following. 4 times 5x gives us 20x, and then 4 times positive 4y, don't forget that the times 4 distributes into both terms, gives us plus 16y, and then 81 times 4 is going to give us 324. Now for the second equation, 5 times 4x is going to give us 20x, and 5 times positive 7y is going to give us positive 35y. And 99 times 5 is going to give us 495. By doing this manipulation, by taking the coefficient of x for the second equation and multiplying it onto the first equation and doing the same for the first equation to the second equation, we end up having two equations now where our x variables are the same. And because of this, we can begin eliminating the variables. I'm going to do the bottom equation, take away the top equation. So we're going to do take away. 20x minus 20x gives us 0, so they cancel out. 35y minus 16y gives us 19y. And 495 minus 324 gives us 171. And the reason I did the bottom equation take away the top equation is to make sure that I don't end up with any negative numbers. If I did 324 minus 495, I'd end up with a negative number. And it's the same for the y variable. 16 minus 35 will give us a negative number. But because I did bottom take away the top, I ended up with positive values. This doesn't always work, and you just have to observe what you're dealing with and make a decision based on that. Now that we have 19y is equal to 171, I can simply divide both sides by 19 to get y on its own. And this is going to give us the following. Y is equal to 9. Now that we found our y value, which is 9, I'm going to take it and input it into one of the original equations. In this case, I'm going to choose to input it into the first equation as we are dealing with smaller numbers. So I'm going to write my first equation out, 5x plus 4y, but instead of the y, I'm going to write down the value we found for it, which is 9, and this is equal to 81. Simplifying this gives us 5x plus 36 is equal to 81. Rearranging for x now, we're going to subtract 36 from both sides. This now gives us 5x is equal to 45. And now to rearrange for x, the final step is to divide by 5. Since we have 5 times x, I'm going to divide by 5 on both sides. This is now going to give us x is equal to 45 divided by 5, which is 9. So our two solutions are going to be y is equal to 9 and x is equal to 9. And if we check our answer, there it is. And that's it for the lesson on solving simultaneous equations using the method of elimination.